is worksheet number 1, limiting reactants in modern chemistry. I'm going to work through this one for you. And so question 1 says the unbalanced chemical reaction, and you need to balance it. So let's balance it first before we ask the question. There's 2 N's and 2 H's, and there's 1 NH3. So 2 N's, 1 N, so I probably need 2 N's there. So now I have 2 N's and 2 N's. I have 2 H's, and I have 2 times 3 is 6 H's, so I need a 3 there. So this one is a 1, a 3, and a 2. We balanced it. Now let's look at what the question is asking us. It's given 28 grams of nitrogen. I like to write my amount underneath there of nitrogen and 25 grams of hydrogen. 0 grams of hydrogen. So now I know I have the amounts of both of these. And when I have a problem where I have the masses of both reactants, those are the things on the left-hand side, it's a limiting reactant problem. I have to find out which one I have the least of. I know this one I have the least grams, but in chemistry we have to do moles. We actually have to see which one has the least moles. But I have a different way of doing that, although you could do the moles. And the rest of the question says how many grams of NH3 can be produced. So I like to put a question mark there and how many grams. So I'm just going to do a line of stoich from nitrogen to NH3, and then I'm going to do another line of stoich from the hydrogen to the exact same NH3, and the one that produces the least will tell me the limiting reactant. The answer doesn't tell you the limiting reactant, but the reactant, either this one or that one at the beginning, will tell you which one's the limiting reactant. So we'll start with 28.0 grams of nitrogen. We'll make our railroad tracks, and we'll change those grams into moles. So 1 mole of nitrogen gas is 28.02 grams. I just took nitrogen from the periodic table and added it up twice. So 14.01 times 2. And so this is our step where we go grams to moles, and then here is where we'll do the mole ratio. And the mole ratio, so if I have moles of nitrogen there, I'm just going to repeat moles of nitrogen down at the bottom to get rid of it. And the thing I want to go to is NH3, so moles of NH3, and these numbers I get from the balanced equation. So there's a 1 in front of N2, and in front of NH3 there's a 2, so it's a 2 to 1 ratio, 2 of those to 1 of those. And then my next step is to change these moles into grams. So repeat moles NH3 here, and I'm trying to go to grams, which I can, and that one's always 1, and then the grams of NH3, if I add them up, is 17.03 grams. And now I do my math. In my calculator, I'll do 28 divided by 28.02 times 2 times 17.03. Let's see if we can do that on here, and maybe you can see it. So we will do 28 divided by 28.02 times 2 divided by 1 times 17.03, and that equals 34. It actually equals 34.0 because we need to have 3 sig figs. We started with 3 sig figs, so we'll end with 3 sig figs. Stoichiometry from the hydrogen to the NH3. So I have 25 grams of the hydrogen. Do my railroad tracks again, probably about that long. And so 1 mole of hydrogen gas is 2.016 grams. I got that from the periodic table. And I'm going to look up at hydrogen. There's 3 of those, so I have 3 moles or 3 parts hydrogen to 2 parts or 2 moles NH3. And now I'm going to change these moles. I'm going to write it down here so I can get rid of it and go to grams. And I wrote it up here already, so I can just copy that down there. A little bit like copy and paste. And I like to write NH3 in either this one or that one just so I remember what I'm doing. And then in my calculator, I will do 25 divided by 2.01016 times 2 divided by 3, and then times 17.03, and that gives me 140.7. I can have 3 sig figs, so that's 141. So that's 141 grams of NH3, and I'll go back and cancel my things out. So that would cancel that, and that would cancel that, and those would cancel that. And I forgot to do it up here too. Deet, 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 deet. And now I look at these answers. This nitrogen, if I had 28 grams of nitrogen, it would produce 34 grams of NH3. And that means if I had unlimited of the other reactants. And if I had 25 grams of hydrogen and unlimited amount of that, I could produce 141 grams of NH3. So I look at these two numbers, and the smallest one is this number. So that tells me that that reactant I have the least amount of, and that one is the limiting reactant. So nitrogen gas is the limiting reactant. And the question actually was how many grams of NH3 can be produced. It would be this answer right there because it's the least. We couldn't produce this because we would need way more than 28 grams of nitrogen gas. So I did 2 lines of stoichiometry. The one that produces the least is the amount that's produced. And then I go all the way back to the beginning, and that tells me which reactant is the limiting reactant. So now we'll move on to the second question. Given 50 grams of magnesium, so I like to write 50 grams there, and 75 grams of hydrochloric acid, how many grams of hydrogen gas can be produced? So I'm trying to find that one. And I need to balance the reaction. So 1 mg, 1 mg. 1 H, 2 H's. I'm going to put a 2 there, so now I have 2 H's, I have 2 Cl's, I have 2 Cl's. It looks like it is balanced, so it's a 1, a 2, a 1, and a 1. And how many grams of hydrogen gas can be produced? I'm going to do stoichiometry from this one to that one, and then from HCl to that one, and the one that produces the least is the amount of hydrogen that gets produced. So we'll start with 50.0 grams of magnesium. We'll do our railroad tracks. And 1 mole of magnesium is 24.31 grams. I got that from the periodic table. Then I'll do the mole ratio. And so I'll have moles of magnesium on the bottom, and there's a 1 there. And then I'll do the one I'm trying to find, which is H2. So moles of H2, there's 1 of those. And then I'll change those moles of H2 into grams. And 2 H2s is 2.016 grams. And then I'll hit enter. So in my calculator, I will do 50 divided by 24.31 times 1 divided by 1, which I don't put in my calculator, then times 2.016, and that equals 4.15. So 4.15 grams of hydrogen gas can be produced with 50 grams of magnesium. So that's my first line of stoic. Now I'll do my second line of stoic, and that would be 75 grams of HCl. Get my railroad tracks going, and 1 mole of HCl is 36.46 grams. I added those up, and then I'll repeat moles of HCl here, and I'll go to moles of H2, and I can repeat a lot of what I have up there. What was moles of HCl? It was 2. And then here I'll do 1 mole of hydrogen gas is 2.016 grams. And then I'll hit equal. So in my calculator, I will do, let's see if I can read this, 75 grams. Let's do a little bit of clear. 75 divided by 36.46 divided by 2. I'm ignoring that 1 times 2.016. And that equals 2.07 grams. 2.07 grams of hydrogen. So now I look at these two, and the one that produced the least is the answer. 2 is smaller than 4, so that's the answer. And that tells me, go way back to the beginning, that I have HCl in a limited amount. So hydrochloric acid is my limiting reactant. And I have one more follow-up question here. How many grams of magnesium chloride are produced? So we need to use the limiting reactant. The limiting reactant was HCl, so we'll just start with that. 75.0 grams of HCl. And then we'll do stoichiometry from HCl to MgCl2. And 1 mole of HCl. I like this because there's a lot of repetition, and I can just copy and paste numbers. That, and then again I'll do moles of HCl. There's 2 of those, and I'm trying to go to MgCl2, And way up here, it looks like there's 1, so 1 MgCl2. I'm getting a little lazy and didn't put my moles in there. It's really the ratio, the parts to the parts. And then, so 1 mole of MgCl2 has so many grams, and that is, I've got to go to our calculator, 36.46 times, I'm correct up, 35.45 times 2 equals, plus Mg is 24.31, and that equals 95.21. So 95.21 grams for MgCl2. I didn't have that one memorized, that's why I had to do that one. And then in my calculator, I will go up a little bit. I will do 75 divided by 36.46 divided by 2 times 95.21, and that'll equal 97.9 grams of MgCl2. And I could go back and cancel grams of HCl, moles of HCl, MgCl2, MgCl2, and that's how much I would produce of that. Okay, this is question number 3. So given 200 grams of silver nitrate and 200 grams of sodium phosphate, so we have 200 grams of that and 200 grams of that. Again, I know since I'm given the amounts of both reactants, it's a limiting reactant problem. I can't look at the grams to tell which one I have the least of. You really have to go to moles, and I have a little different way of doing that. And the question says how many grams of NaNO3 can be produced. So I'm trying to find how many grams of that can be produced. And I first of all have to balance the reaction. 1 Ag, 3 Ags. So I'm going to put a 3 there. Now I have 3 Ags. I have 3 NO3s. I need 3 NO3s over there. I have 3 NAs, 1 PO4, 1 PO4. It's balanced. So that's a 1 and that's a 1. So how many grams of NaNO3 can be produced? So I'm going to do stoichiometry from the first one to that one, and then stoichiometry from the second one to that one. So we'll start with 200 grams of AgNO3. These are bigger compounds. I'm going to change it to moles. So 1 mole of AgNO3 has a certain molar mass. How about 169.87 grams? And then I'm going to change those moles of AgNO3 into moles of NaNO3. And in front of this number, or that compound is a 3, and in front of that is a 3, so it's really a 1-to-1 ratio, but I do write 3 and 3 in there. And then 1 mole of NaNO3, I change that to grams, and that is, I'm going to my cheat sheet for this. It's 84.99 grams, 84.99 grams for NaNO3. In my calculator, I will do 200 divided by 169.87 times 3 divided by 3, which really isn't necessary, and then times 84.99, which equals 100.06, so it's 100.1. How many sig figs? 1, 2, 3, 4. So we'll do 100.1 grams of NaNO3 can be produced from 200 grams of silver nitrate. Now we'll do the next one. Didn't leave myself so much room here. 200 grams of Na3PO4. I'm going to do this another line of stoichiometry. So 1 mole of that would have 163.94 grams. And then I'll do the mole ratio. There is 1 Na3PO4 for 3 NaNO3. So if you haven't noticed that box and that box are the same, and then that box will be repeated there and that box will be repeated there. So 84.99 grams of NaNO3 for 1 mole of that substance. And now we'll do a little bit of calculator work. So 200 divided by 163.94 times 3 divided by 1, which I'm ignoring, and then times 84.99. Did I plug that in there right? Looks like 311, and we have to do 4 sig figs, so How about 311.1 grams NaNO3, but it really is irrelevant because when we look at these numbers, we have 311 and 100.1. The one with the least is the winner. It's a little bit like a round of golf. The lowest number wins. And I know the next question is going to be what compounds the limited reactant. This is not the limited reactant, but the thing we started with. So that one is the limited reactant. So I will circle that one. And of course, there's a follow-up question. How many grams of Ag3PO4 can be produced? So now that we know the limiting reactant, we'll do stoichiometry from the limiting reactant to that next one. And the good news is that we can just repeat some of this information. So 200 grams of AgNO3, and I'm just going to steal some of my info from up there. If I did it once, then I can just write it down. So 1 mole of AgNO3 is 169.87 grams. I added that up from the periodic table. There's 3 AgNO3s. Let's double check. Yep, 3 AgNO3s for 1 Ag3PO4. And then we'll change that 1 mole of Ag3PO4 into grams. And I'm going to look at my cheat sheet for that. It looks like 418.58, and 8 must say grams. And then I'm going to do a little math and do a little dance. So in my calculator, I will have 200 divided by 169.87 divided by 3 and times 418.58. That equals 144. Did I get that right? Oh, I can't read. 164.3. 164.3 grams of Ag3PO4. I would put a square around it. I might go back and cross out my units. It brings me joy. And that is the one I'm left with. I always like to check, and that's what I'm left with. Oops, so there's the answer. I hope that helped you. I hope it was better that I actually wrote it out for you. I got myself a little phone holder, and it's holding my phone. It's a little awkward and weird. I'm sure you can hear my children in the background. I hope all is well. Please reach out to me with emails if you have any questions. Talk to you soon. Bye-bye.